Good evening, everybody, and welcome to GlugNet. My name is Stephen Ball, and I'm currently serving as the president of GlugNet. Tonight, we are pleased to welcome Shawn Wildermuth, who will be speaking to us about C# code generation. But first, a little bit about us. We are the Greater Lansing user group for .NET developers, based out of Okemos, Michigan. Our meetings are every month on the third Thursday. We are free and open to the public. The best way to find out more information about what we have coming up is on our meetup page, meetup.com/glugnet. Our meetups are typically recorded and posted to YouTube by our own Sam Nasser. You can find his channel either using the QR code on the screen or by going to youtube.com/@SamNasserMVP. Before we get started, a few housekeeping items. We are always looking for lightning talks before our main presentation. So if you have a 10 to 15 minute talk on a tech topic that you are near and dear to, we would love to have you. You can either contact myself or Joe Kunk, and we can get you scheduled before a meeting. Tonight's presentation is interactive. Feel free to ask questions of our speaker or answer questions he asks us. If you are not comfortable speaking up or just don't have the ability to, that is fine as well. There is a chat feature in GoTo that we will be monitoring for questions. Otherwise, we please ask that you stay muted so that we can all enjoy the presentation. At the conclusion of tonight's presentation, there will be a survey made available to all attendees. We are looking for feedback on two things primarily. First of all, how did we do promoting the event? And second, feedback on the presentation itself. All feedback collected is completely anonymous, so please fill out the form for us and give us your honest feedback. Good, bad, somewhere in between. We want to hear it all. And Shawn, yeah, and Shawn, a copy of that feedback will be sent to you as well after we've aggregated it. At this point, I'd like to take a moment to thank our sponsors for the evening, NIS Technologies, who is providing us this go-to session, and the .NET Foundation for their financial support of GlugNet. So now, as they say, it is time for our featured presentation. All right, take it away, Shawn.
So hey everyone, I want to talk today about source generators. I know before I looked at them, I felt like they were very daunting and I wasn't sure really what they were about. And so I'm going to talk some about why they exist, how they work, and we're going to actually write a very simple one at the for the latter half of the talk, or the latter 90% of the talk probably. If you don't know who I am, I'll have some links at the end. You can find me, and that'll include the source code for the talk we're giving today, as well as copies of the slides. I'm an MVP for 20-some years now, Docker captain, instructor, and consultant. Always love to hear from people afterwards, so if you have comments during the talk, using chat would be great, or just speak up. I don't mind being interrupted. And let's talk about source generators. So a source generator is kind of a simple idea, but it can be, if you've never dealt with Roslyn before, it can be a bit much to sort of grasp your head around. Roslyn is the C# compiler platform, and so it knows about the code you're working with at a very low level, both as it parses C#, but also how it takes that parsed C# and produces assembly. That's all part of the Roslyn work. And so when we compile our application, and this compilation is not just when you press Control F5 or whatever the keyboard combo you're using to compile your application. It's also if you're using Visual Studio or Visual Studio Code or Writer as well, there's background compilation that goes on to help with IntelliSense and things like that. So the compilation is happening quite a lot in here. And so when the compilation happens, if there's a source generator installed, it passes the information it has gleaned from the parsing to a source generator. Source generator then is executed, and it's going to analyze the atom of code that the compiler is working with at that moment. You're not given the entire code base or even on a file. You're being handed one small thing at a time, so you can determine whether you care about it or not. It then generates new source code that then is included in the compilation, so that it is then contributed to your source code, and then the compilation continues. And this can happen over and over and over again. And so when we look at how to write these things, one of the important ideas is that source generators have to be incredibly fast, especially when they're not actually doing anything. And this is to really not slow down the compilation step, especially if what you're doing doesn't matter as much. So if you're just rejecting, oh, they're not using this attribute that I'm looking for, I need to return back as fast as possible. And so sometimes slowness in Visual Studio and Writer, less so in Visual Studio Code, can be attributed to bad source generators that can sometimes happen from third parties. So source of great power, but also can, if they're not well written, can really be a problem. So the idea behind source generators is one of the main ways they're used is as an alternative to reflection. So it moves the code gen of what reflection can do, both in emitting but also in parsing of metadata, to compile time instead of to runtime. And because it's at compile time, it also unlocks AOT building or AOT trimming. So if you're using ahead of time compilation to build smaller apps, CodeGen will support that, whereas if you're using reflection, most of AOT doesn't work. Because that's one of the things it likes to trim out is all of reflection, since it tends to be big and slow. So what it does in this CodeGen is actually produce code files. It's physically creating code files, and that's empowering us to have better tooling. Again, a lot of this is driven by not only improving the developer experience, but also improving the runtime performance. This is based on the idea of analyzers, which maybe some of you have written before, that allow you to do things like throw errors and warnings when you see certain patterns in code, and it takes that one step further, where we see something in the code that we're interested in, and we want to augment it. So I hope that was clear. That's the end of my talk. Oh wait, no, I should do the demo. So here in Visual Studio, I have a really stupid little project. All this console app does is list all the classes that are in its project. And you can see bar, foo, quux are three of the types. And here I'm using reflection to just list them, right? Again, not very realistic, but I think this is a good way to look at this. So it notices that there's classes in here. And I'm going to focus on CodeGen for classes, though you could be doing this CodeGen on attributes is really common, or on other patterns you're going to see in code. So we can see it does it. All that's good. But if we open up a console real quick, and I do .NET publish, and I'm just going to build into a folder called no AOT. I'm just going to publish it just like I normally would. Should be really quick because it's a tiny little project. And here we can see, if I can make it big enough, that it's a pretty small project. That's not going to help me any, because I need to see the sizes. So the actual executable is 136, and the actual DLL is 6K. Really, really small. Now, in case you don't know this about how the way .NET compiles, this exe actually isn't your code. It is the .NET the .NET tool so that it can run the DLL. It's a little trick they've done to sort of have this be the Kickstarter, but all your code is really in that DLL that you built for the console app. Now, what if we go ahead and change this project to turn on AOT? I'm going to uncheck that. And now it says when I publish, I want it to actually be AOT. So I'll just do it again. I'll put it in a different folder. No one make fun of me that I had AOL on the screen for a second. And immediately you'll see that there's some warnings. Warning, get types from reflection. Types might be removed during the trimming. And there's going to be another. So let's go ahead and look at our AOT folder for a minute. Just like we did before. And one, it's a lot bigger, because in AOT compilation, you're actually producing not IL, but actual compiled code that runs on a particular type of hardware. And the EXE is going to be bigger than it was before, but it actually doesn't require .NET at this point to run. That's one of the things with AOT that's important, is you can copy this to a Mac, you can copy this to really anywhere, and it will run without the .NET framework being installed at all. And if we, let's go back to our console. Let me go into the no AOT for a second. If I run our class list exe, we'll see that it showed just like it did before. We published it, no AOT, it works fine. But if we go to the AOT one, remember it compiled, but it doesn't do anything because it has trimmed out all that reflection code. Does that make sense? I'm hoping you're all nodding your head, because I can't see you. So why did I bother showing you all this? Well, the reality is one of the most common cases for this is to remove the need for reflection. You'll see a lot of different libraries that use code generation to sort of push this stuff forward. So we have a class generator over here, and let's go ahead and write something that's actually going to help us out with this. So I'm going to, first I need to add a couple of NuGet packages, and we will see exactly how slow it might be. So I'm going to look for code analysis. And so you can see code analysis analyzers in C#, and we actually need both of them. So I'm going to download that one first. And if someone knows why this caching of the vulnerabilities takes so long in Visual Studio, I'm welcome to hear suggestions. I've talked to a lot of people about it. I cannot figure out why the first time it runs it takes 20 or 30 seconds. At the command line, it does not do this, but I like to show this as using the NuGet package manager, because that's the way most people use NuGet these days. Come on, you know you want to. Okay, there we go. I'll also need the analyzers. Thankfully, the second one is much, much faster. X and X, yeah. So with those installed, I can use a interface called, I'm going to cheat for a second because I can't remember what it's called. So, there it is. incremental generator. And this is in the code analysis namespace. And this is what makes it a code generator. Also, we need to say generator as a attribute to tell Roslyn that this is in fact a real generator and a generator that we expect it to use. So I'm going to go ahead and implement the interface, and the whole interface is a very simple initialize that we're going to use. I love these long class names that you'll run into a lot with Roslyn. Very clear, but very long. And you can see we actually still have a warning here. That's because in order for this to do what we want, we actually have to add one more piece up here, which is enforce. Let me steal that name as well, because I always type it wrong. Force extended analyzer rules. By knowing about how this class generator is set up, we when you do this, let's say on a NuGet package or sharing of a project, it will automatically do these fix-ups to the C#. This is only for development that some of this becomes a little looking under the covers. And if we wait long enough, yeah, it goes away. So we now have a generator, and we're going to want it to do something. So let's start with that context. This is where some of the code gets a little terse, so I'm going to be stealing a little of it. And what we want to do in here is create something called a syntax provider, basically a way to look at what we care about as the syntax is being parsed. This takes two properties, and I think they're both lambdas, right? Yeah. So predicate, which is one of the things we need, is essentially a static lambda that is executed to do some filtering. If this comes back as false, it just goes back to Roslyn. So this is the code that needs to be really fast. You'll notice we're even making the lambda static in order to make this as quick as possible. And all I care about at this point is that the node that we're being passed is a class declaration. That's all I care about. If it's not a class declaration, I don't need to do anything about it. So if you were going to do this based on an attribute, you were going to do this based on a property, you would change the kind of thing you're looking at. And you could even do more analysis, but try to keep it as brief as possible, because you're going to have a second bite at the apple called transform. And our transform is really pretty simple. We're saying if it passes the predicate, I'm going to get the context of what's being called, and I'm just going to return just the class declaration that I care about. I'm just doing that by casting the node, which we confirmed here was a class declaration, so we don't need to do any type checking there. And you would think we're done, but we're not done. After that, we need, here it goes. And we're just going to put a where on here, so we're only going to get the items we need. And in our case, again, I'm making the lambda static so it doesn't have to recreate it much. All I'm going to do is say M is not null. I just want to make sure that what we're getting back from this class declaration doesn't happen to be null. Just a nicety. If it's null, then we should be ignoring it anyway. And then I'm just going to want to get anything in this provider by calling collect that matches it. And this may be one node at a time. This may be a handful. Roslyn is going to determine what you're going to get here. And it's going to create something called the compilation provider. Basically, the thing that can do compilation we're going to need here, because we're going to take this context and register source output. And this is where we're saying I'm going to create some code for you to include in your output, and I need to tell you that I'm going to be creating it. And all that this needs is the compilation, one that's going to include the things we collected. And it takes a lambda, but I'm going to make it into a whole method because it's a little more complex than it needs to be. And I'll call this class execution, or whatever we want to call it. I'm just going to generate a method for that. And you'll see here that what it actually produces can be a little confusing. It's giving you that context for what we might want, but also giving you a tuple that has a couple of pieces of information, most notably the collection of class declarations that we're noticing that we need. Let me make sure I didn't do that. Yeah. In this, I'm just going to first create some code. So here, I'm just using basically a piece of string to say, this is what a class should look like. So what's interesting here is we are generating source code, why it's called a source generator. We're not generating, what's the word I'm looking for? Code objects that would be included. We're actually producing source code that is then going to be parsed by Roslyn as well. So that's why you get this, and gives you some flexibility in how you build it. And frankly, this is a lot easier than creating a new class declaration and then creating a constructor and all that other stuff. This is going to be a lot simpler to sort of get your head around. And we're just going to say context. Make sure I have that right. Yeah. Add source, and we're just going to give this a name, and I'm going to call this class list generator. And one of the things you've probably noticed before is there's also a You'll notice that some classes that you end up debugging have this little .g before the CS, and that's just a convention they use so that you know it's generated. So whenever you look at source code that you might be debugging and run into a .g.cs file, that was generated by a source generator. There's quite a lot in Visual Studio or in .NET in general that you probably haven't seen under the covers. And here I'm just going to pass it that code. Right? We're not really investigating anything. I'm just producing a very static little piece of code here. So luckily for us, I had already made reference to this. Why isn't it there? Hold on. Luckily, I said, because I'd already made a reference, but I hadn't. I was gonna, in case you don't know, this is usually the trick. Everyone is the only thing anyone can remember from my talk, is that if you grab a project and drop it on the other project, it makes a project reference. Doesn't happen that often. It's not going to save you a ton of time, but it'll help. And so let's comment out how this works. And let's say class types equal, what did I call the class? Class names. And here you'll notice that as you're working with the generator, it's not going to find this as much as you would like it to. And that's because it doesn't know that this has been generated. Let me go ahead and build just this for a second, just to make sure that doesn't solve it for us. Usually doesn't. Usually I have to come up here and restart Visual Studio. Usually happens only on the first compilation, and then you can continue working without restarting it over and over again. Or I typed the completely wrong name. Nope. Okay, I think I missed something. Hold on a second. I did. So at this point, the project reference is just loading the DLL, just like it was any other any other library that we might use. We actually have to do one special thing with the project reference, and that is output item type. So you're telling it that what this is it's not an assembly to be included, it's actually an analyzer. And again, when you create your own generator and someone adds it to the project, they'll know to do that automatically. But because we're developing the generator, that's not the case. And so now that I've done that, notice it immediately found it. You're going to ask yourself, well, did you need to reset? Maybe not. And instead of full name, we're just going to give it the name, right? Because what we've created here is just a list that has one name in it. So if we run this, we should only get that some class name. And it's because this has been generated and included in the project. But of course, this is virtually useless, right? We actually want to be able to do the things we want to do in the generator. So let's come up here, and I'm going to dereference the left as the compilation and the list from the tuple. Just a cheater's way to not have to use the tuple object every time. And we're going to just say class names equals new list, a string. I always forget that it should be included in every project. And we're just going to go through our list. Name and list. We're just going to say class name. Class names dot add. And we're going to use the, we're just going to include the name here. Now, the name here, when we're going through it, is just going to be a string already. So you'll notice that this is class declaration syntax. When we're going through these, did I do that right? Yeah. Then I'm going to have to go ahead and just get its name. Come on, go away. Where is it? Oh, yeah, of course. This is where it gets a little wonky. So in each one of these, because what we're being passed here is actually the class declaration syntax, is we need to jump through a couple of hoops to get at the name. So the symbol for our class, we're getting it from the compilation, and where do I get the syntax? That is confusing. I might pull out the afterwards, but where the heck is the syntax? Oh. Probably all yelling at your screen now what I did wrong. And so we're effectively saying, go look at this syntax tree and get a semantic model of it, and then go get a declared symbol of that name as just a named type symbol. What this is going to allow us to do is this symbol, which is an inName type symbol, effectively the name of the class, is just say class names dot add. I'm going to use some magic here so I can put it in quotes I'm going to say name. Whoops. Name. I used to be good at this. Yeah. To, it's not to full string, is it? No. I'm sorry. Symbol dot to display name. The display string. Now, all this is going to do is create us basically a set of strings we can put in. So what we're actually going to do here is put in a carriage return at the end as well, and I'm going to give it a sort of a leading 4 characters so it actually looks okay. And then what we can do, I don't know if you've ever used $2 but that we're using $2 because the single bracket that you would use in a $sign string here, we're already using them. So by using 2, I can actually come in here and just say use 2. It's always the number of the $signs you have, and I'm just going to say class names. Oh yeah, that's right. Let me take this out. Did this differently a minute ago. String.join. And here we're going to give it that n. There we don't want the thing because we want the /n to actually be a carriage return. And I'm just going to pass in our new class names. It's the only part of doing these talks remotely that gets a little hairy because I can't see whether you guys are getting it or I'm confusing you. But we'll find out in a minute. So just to walk through it really quickly, we're trying to get all the class names that we want out of this class declaration. We'll go through the list of class declarations we have, walk through and get the part of the name that we care about, and this is actually just the name of the type. I'm going to go ahead and generate individual strings for each of those types. Oh, I forgot to put a comma there. We're going to join them into a string. And we're just going to inject that into the code gen we're doing. And if I've done this right, we can see we're now pulling it out just like we were before with reflection, except this is being composed at compile time. So at compile time, we actually end up with a file. Let me see if it'll let me go to a name. Navigate to it. Nope, that's the, rerun the generator. Come on. It aggressively caches these, so it becomes harder to do that. Let me try one more time. Nope, it will not let me do it. But let's cheat a little, just so you can see it. If we go down to the obj, we're running debug. Oh, I don't have it outputting. Never mind. It's not going to be in there. There's an option you can do to have it output just so you can sort of debug what it looks like. But that's sort of the magic here. So in our program, let's go ahead and add a new class. New class. Again, we just care about its name. But if we run it, that's going to change the generated code, and there's our new class being included in there automatically. And in this way, we can go ahead and rerun AOT after. get the same sort of thing that we have these files. They look bigger here than they did in File Explorer, but if we run it, it also works, even though it's trimmed, because the generation code isn't trimmed out, only the reflection stuff. And let me show you an actual project that I've used this for, so you can see sort of what a real generator looks like. Projects, APIs. So I have a project, I have a couple projects for minimal APIs, and one of them is this discovery generator. This basically goes through and finds classes that have an interface. And so the generator, which is pretty simple, you can see a lot of what we've already done. And instead of the predicate knowing what it wants, I'm actually using a little helper function here, which I'll show you down here. Oh, it's just doing the same thing. So it's looking for that class declaration. So that, in fact, was exactly like what we do. In execution, I'm going to do something a little different. I'm going to look at the type list that I'm being passed in. Well, let's go back for a second. When I transform it here, I'm actually gathering more information than you might imagine. So what the get target does is looks at the class declaration it got, gets the symbol, the declared symbol, so that it can say, if this is an abstract class, ignore it. If this is interfaces have more than one interfaces, then we need to do this sort of digging into each of the interfaces, because what we're looking for is this interface. We're looking for someone to use IAPI on a class, and so we're only going to be interested in the ones that are those classes. And if we are, we're going to give it all the information we need. So that by the time we get to the execution here, we can say, hey, is there nothing in the list? We can ignore it. Otherwise, we can start, and I'm using the string builder because it'll make it a little easier for me here. And once I put in all this code that is going to be for these generated classes, I can do a few things. First, if there's something wrong with that class that I need to warn them about it, API classes should have an empty constructor. I can actually throw diagnostics that you'll see at the in Visual Studio or in the compilation result in Visual Studio Code, that the reason I can't make this work is that it has to have an empty constructor. Okay, fine. And then all I do is I'm calling each one of those interfaces as they need. So only when we add a new class is my generator being actually run. And it's generating this file that just does the registration of each minimal API on startup. That's all it does. And so this effectively does a little magic so that if you have an IAPI on the class, in startup you call map APIs, and it'll just call this method that we've created. This method just has this call for each API class that's out there. Where are we? Here. Almost there. I guess I stopped it. Questions? Or
Yeah, I've got a question.
Oh, good.
Yeah, so, and you kind of already answered this with your second demo, but what are some of the more practical uses of this technology other than just listing out, your classes that you have in your project?
Yeah, I mean that is the least, like, that isn't even useful, the demo I showed you, frankly. But what you'll see is there's a lot of occasions where you might be able to infer things or help things. So there are class generators for looking at properties and then creating wrappers for those properties that might be able to handle like reactivity. So someone only has to put the property on, but because you're generating code for it, you might be able to do more interesting things. So it's about simplifying the code, even if the generated code is more complex. Now we see this in some ways in what the compiler has done, like the compiler magic of partial classes is just that the compiler goes, let me find all the partial classes and put them together. Some of that stuff's being pushed to source generators because it then doesn't slow down the compilation. It just can look at the things about it. Probably the most common usage you're going to see is to either apply attributes so that the user doesn't have to, or the reverse, and do something special because the attribute exists. So there's some attributes out there that will go ahead and create a proper override of equals for certain kinds of objects because you've used an interface to do this or that. Many of the source generators that you use every day that you don't know about are in the Roslyn GitHub. And so you can actually look at real world ones and how they work. Did that help?
Yes, definitely. Thank you.
Good. Now, source generators are not something you're going to write very often at all. Every once in a while in a large project, there'll be an opportunity where you go, oh, that would be helpful. Just like if you're writing analyzers, you might have a couple of analyzers about this use case that your project has, and you want to be able to warn the developer to avoid some pattern. Not very common to do, but having it as a arrow in your quiver can be really helpful. Other questions? I'm going to have to start picking people if you don't. I'll just give you the quick takeaways. Search generators are up on MS Learn. That's a link you can get to them from. I have a few talks on source generators up on my YouTube channel. So Shawn link.yt or .NET source generators. I should have removed this. I'm actually doing a workshop in February, and if you go there, you'll be able to see tickets, but it's not available yet, so I didn't mean to show you that. But if you're curious, I will be doing another online workshop coming up soon. And the Minimal API Discovery project I have, this will take you to the GitHub, where you can use it if you're doing large-scale or Minimal API projects. Thanks for letting me be here. Let me just check the GoToMeeting, make sure there's no comments. Oh, thanks, Stephen, Stefan, for some examples. Yeah, the MVVM toolkit has a really cool source generator to allow for iProperty changed interface. Yeah. So that's all I have. How did my guess of 45 minutes work? Oh, actually almost right.
Right about on time, yeah. Thank you, Shawn. That was wonderful. Any last comments or questions for Shawn?
Just I appreciate your time, taking your time out of your busy holiday season to help educate us.
Awesome. And feel free to reach out to me at wildermuth.com. That's also where the blog is, where the source code will be in a couple days.
Perfect. All right. I did drop a link in the chat for the survey, so if everyone would please take a moment to fill that out. That will be left open for the next 24 hours. So if you need to think on it for a little bit, that's totally cool. And I'll close that tomorrow evening and then get the results out to you, Shawn.
Awesome. Sounds good. Well, thanks, everyone. Have a good holiday.
Thank you. You too.